Welcome to our first online mathematics class, and I'm Sir Ron Alfie Huson, mathematics teacher of Calaba National High School, Division of Nueva Ecija. So at the end of the lesson, the learners are able to define arithmetic sequence, find the indicated term of an arithmetic sequence, and solve problems involving arithmetic sequence. But before we begin discussing our lesson, let's first have some math exercises. So are you ready? Okay, time's up. The answers in the problem are 22, 27, and 32. I hope you got the correct answer. Now let's have our second problem. Ready? Time's up. The answers in the problem are 52, 61, and 70. Good job. Let's have our third problem. Ready? Okay. The answers in the problem are 32, 26, and 20. So I hope you got perfect in these three problems. So let's continue with our discussion. Let us now consider the sequences below. As you can see, these are the sequences that you have answered a while ago. What can you observe about our first sequence 2, 7, 12, 17, 22, 27, and 32? You are correct. In the first sequence, the number 5 is being added to the previous term to obtain the next term of the sequence. So 2 plus 5 equals 7, 7 plus 5 equals 12, 12 plus 5 equals 17, 17 plus 5 equals 22, and so on. Now what have you observed about our second sequence? 16, 25, 34, 43, and so on. Yes, indeed. In the second sequence, the number 9 is being added to the previous term to obtain the next term of our sequence. So 16 plus 9 equals 25, 25 plus 9 equals 34, and so on. Now let's proceed to our third sequence. Any observation? Yes, you are correct. In the third sequence, a number is being subtracted to obtain the next term. So in this case, the number 6 is being subtracted to the previous term to obtain the next term of our sequence. Or we can also say that the number negative 6 is being added to the previous term to obtain the next term of the sequence. Now generalizing this, as you can see in the sequences, in the first two sequences, the numbers are increasing in value. So the number that is being added is a positive number. While in the third or in the last sequence, the number that is being added is negative. That's why the numbers in the sequence are decreasing in value. These sequences are examples of the so-called arithmetic sequence. Now, what is the arithmetic sequence? To formally define arithmetic sequence, an arithmetic sequence is a sequence where every term after the first is obtained by adding a constant called the common difference. So the examples a while ago are all examples of arithmetic sequences. Let's take another example. So given the sequence 4, 7, 10, 13, 16, 19, 22, and so on, what do you think is the number that is being added? Precisely, the number that is being added to obtain the next term here is 3. Now, the number that is being added to obtain the next term is what we call the common difference. So in arithmetic sequence, there is always a presence of the so-called common difference. Now it's time for you to create your own examples of arithmetic sequences. You are required to write only 3 sequences on your notebook. So you may pause our video for you to have enough time to work on this activity. Now let's have a different problem. Let's try to solve this problem. Okay, I'll give you time to analyze our problem. You may pause our video for you to have a clearer understanding of the problem. Now let me read our problem. The data below show the monthly rent in pesos of an apartment in Nueva Ecija from its first to fourth year. So in the first year, the monthly rental fee is 2,500. On its second year, the monthly rental fee is now equal to 3,000 pesos. In its third year, the monthly rental fee is 3,500 pesos. And on its fourth year, it's equal to 4,000 pesos. Notice that the sequence forms an arithmetic sequence, or the numbers form an arithmetic sequence. Now the question is, what will be the monthly rental fee in its 20th year? Do you already have your answer? Now the answer here in the problem is, yes, you are correct, 12,000 pesos. Now let's list down all the numbers until we come up with the 20th year. So in the first year, it's 2,500, then is 3,000, then we have 3,500, followed by 4,000, and so on. So it is an example of an arithmetic sequence where the common difference is 500. So if we follow and continue our pattern here, the 20th year is now, in its 20th year, the answer is 12,000 pesos. So what if you are asked to find the monthly rental fee in its 50th year? How about if you are going to find the monthly rental fee in its 75th year? What if you're required to find the monthly rental fee in its 100th year? It seemed that doing those activities, it requires you a lot of effort to find the missing numbers. Now the question is there an easy way for us to solve such problem which involves arithmetic sequence? So the point is, without using or listing all the numbers until you come up with the indicated term, is there a more convenient way to solve such problem? You are correct. So we can use a formula to solve such types of problems. The formula that we are going to use here is this. The general term of an arithmetic sequence is denoted by a sub n equals a sub 1 plus quantity n minus 1 times d. I'll repeat. That's a sub n is equal to a sub 1 plus quantity n minus 1 times d. So in the formula, a sub n is the general term. A sub 1 is the first term. N is the position of the term, whether it's second, third, fourth, and so on. And D is our common difference. Now let us apply the formula in solving arithmetic sequence problems. Let's have our first problem. So I'll give you time to analyze our first example. Our first problem is, what is the 18th term of the sequence 4, 7, 10, 13, and so on? As you notice, our sequence is an example of an arithmetic sequence. So how are we going to solve this problem using our formula? The first thing that we should do is to write down our given. So let's write down the given in our problem. So our sequence is 4, 7, 10, 13. Our first term is 4. So we write a sub 1 is equal to 4. Next is to write down our common difference. So what do you think is the common difference in the problem? Yes, you are correct. That is 3. How did we get 3? To get the common difference, we simply subtract any two consecutive terms of our sequence. So in this case, let's take the second and the first term. So subtract 7 by 4. 7 minus 4 is 3. So therefore, the common difference in the sequence is equal to 3. We are asked to find the 18th term of the sequence. So that means a sub 18 is missing. That's what we are looking for. Now let's write down our formula. What is the formula for arithmetic sequence? Our formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d. Again, that's a sub n is equal to a sub 1 plus quantity n minus 1 times d. So let us substitute the given values. We are looking for a sub 18, so this will be replaced by a sub 18. All n's in the formula will be replaced by 18. So a sub 18 is equal to, what is our a sub 1? In the given, a sub 1 equals 4, so simply substitute. So substituting 4, we now have 4 plus quantity. N will be replaced by 18. So that's 18 minus 1. Our common difference is 3 in the given, so substitute. So that's 3. So we have a sub 18 is equal to 4 plus quantity 18 minus 1 times 3. Now let's continue. So here we are going to subtract first 18 by 1. Note, in PEMDAS, we need to perform operations inside the parentheses first. So doing that, a sub 18 is now equal to 4 plus, what is 18 minus 1? Basic na basic, 18 minus 1, that is equal to 17 times 3. So we have a sub 18 equals 4 plus 17 times 3. Next is to multiply 17 by 3. And what is 17 times 3? Correct. 17 times 3 is equal to 51. So let's continue. A sub 18 is equal to 4 plus 17 times 3, that is 51. Last step, add na lang natin to. A sub 18 is now equal to 4 plus 51. Definitely, that is equal to 55. Therefore, a sub 18 is equal to 55. The 18th term of our sequence is 55. Okay, I hope that you have understood the step-by-step method of applying or using the formula in solving problems involving arithmetic sequence. Now let's have our second problem or second example. Try to analyze our given problem. Our second problem is find the 35th term of the arithmetic sequence 5, 8, 11, 14. So again, first thing that we should do is to write down our given in the problem. So let's write down the given in the problem. So we need two things here, the first term and our common difference. So what do you think is the first term of the sequence 5, 8, 11, 14, and so on? Correct. Our first term is 5. What do you think is our common difference? Yes, correct. The common difference is 3. How did we get 3? So just like what we did before, we simply take the second and the first term, or any two consecutive terms of the sequence. So since 8 minus 5 is equal to 3, therefore, the common difference in the sequence is equal to 3. We are asked to find the 35th term of the sequence. So therefore, a sub 35 is missing. To find a sub 35, we're going to use the formula for arithmetic sequence. And our formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d. So that's a sub n equals a sub 1 plus quantity n minus 1 times d. All n's will be replaced by 35 since we are looking for the 35th term. So let's do it. Let's perform substitution of values. So this becomes a sub 35 is equal to, so a sub 1 equals 5. So we substitute. That becomes 5 plus quantity. All n's will be replaced by 35. So 35 minus 1 times our common difference. So our common difference here is 3. So substitute 3. We now have a sub 35 equals 5 times quantity 35 minus 1 times 3. First is subtract 35 and 1. So let's continue. A sub 35 is now equal to 5 plus 35 minus 1, basic na basic, that is equal to 34 multiplied by 3. Next is multiply 34 by 3. So what is 34 times 3? Okay, that's correct. That is 102. So even if we're going to multiply it here, 34 multiplied by 3. So 4 times 3, that is 12. So write 1. 3 times 3 is 9 plus 1, so that's 10. So 34 times 3, that is equal to 102. So we now have a sub 35 is equal to 5 plus 34 times 3, that's 102. Last step is to add these two numbers. So a sub 35 now is equal to 5 plus 102, correct? That is equal to 107. Therefore, a sub 35 is equal to 107. The 35th term of our sequence is 107. I do hope that you can still follow our discussion on arithmetic sequence. So let's take our third example. I'll give you time to analyze our problem. Let's proceed to our third problem. Our third problem is find the 31st term of the sequence 18, 16, 14, 12, and so on. Now, before we begin solving, what have you observed about our sequence? Our sequence is 18, 16, 14, 12, and so on. You are correct. As you notice, the sequence is now decreasing compared to the previous sequences that we have solved. So just remember that if the sequence is increasing in order, our common difference is always positive. Now, if the sequence is decreasing in order, that's the time that our common difference is a negative number. So here, we expect a common difference that is a negative integer. So the same thing that we did before, first is to write down the given in our problem. So let's write down the given for this problem. Okay. For the given, we need two things, the common difference and the first term. So given the sequence, what is our first term? Very good. Our first term, or a sub 1, is equal to 18. What do you think is our common difference in this case? So to get the common difference, we subtract the second term by the first term. What is 16 minus 18? It's not 2. So 16 minus 18, that is equal to negative 2. So our common difference this time is negative. So it's negative because our sequence is decreasing in value. So we are asked to find the 31st term. So therefore, a sub 31 is missing. So our formula for arithmetic sequence is a sub n is equal to a sub 1 plus quantity n minus 1 times d. Let us substitute the given values. So we're asked to find a sub 31. This will be replaced by a sub 31. So a sub 31 is equal to, what's our a sub 1? A sub 1 based on the given is 18. So substitute. So that's 18 plus, and here will be replaced by 31 also. So 31 minus 1 times our common difference. This time our common difference is negative 2. So let's multiply this by negative 2. Don't forget to place a pair of parentheses for negative 2. Okay? So let us first subtract 31 minus 1. So a sub 31 is now equal to 18 plus 31 minus 1, basic na basic, that is equal to 30 times negative 2. So dito naglagay tayo ng parenthesis dahil kung hindi tayo maglalagay ng parenthesis, so that will be implied as subtraction. So remember here that we are multiplying. So let's continue. A sub 31 now is equal to 18 plus. Let us first multiply 30 by negative 2. What is 30 times negative 2? Correct. Applying the law or the rule for multiplication of integers, positive times negative is negative. So 30 times negative 2, that is equal to negative 60. Now a sub 31 is equal to. Now what is 18 plus negative 60? Recall the rule in addition of integers that whenever you're adding numbers of different signs, you're going to subtract these numbers and follow the sign of the number with the greater absolute value. So ang gagawin natin is pagmaminusin natin siya. Bakit pinag-minus? Dahil magkaiba sila ng sign. So let's subtract 60 minus 18. So 60 minus 18, this becomes 5. So this is 2. 5 minus 1 is 4. So that is 42. But since negative 60 has a greater absolute value, susundin natin yung sign ng negative. Okay? So that will be negative 42. So therefore, the 31st term of our sequence is negative 42. Okay, I hope that you are still there. Now let's have our last example. I'll give you time to analyze our last problem. Now let's have our last problem for this lesson. Our last problem is find the 10th term of the sequence whose first term is 8 and whose common difference is 7. In this problem, it is already indicated the first term and the common difference. So let us underline these two numbers that we need. Our first term here is 8 and our common difference is 7. So let us write down the given. Given in this problem, since it's already indicated in the problem, first term is equal to 8 and our common difference is equal to 7. we're asked to find the 10th term of the sequence. So a sub 10 is missing. So our formula is a sub n is equal to a sub 1 plus quantity n minus 1 times d. We're going to replace a sub n by a sub 10. So a sub 10 is equal to, what is our a sub 1? A sub 1 is 8, so substitute. So that's 8 plus quantity 10 minus 1 times our common difference. Our common difference here is 7, so times 7. We now have a sub 10 is equal to 8 plus quantity 10 minus 1 times 7. First subtract 10 by 1, so what is 10 minus 1? Basic na basic, that is equal to 9. So we now have a sub 10 is equal to 8 plus 10 minus 1, that is 9, times 7. A sub 10 equals, so here you're going to multiply 9 and 7 first. So copy 8 plus, what is 9 times 7? 9 times 7, that is equal to 63. A sub 10 equals 8 plus 63, correct? That is equal to 71. Therefore, the 10th term of our sequence is 71. Okay, I do expect that at this point in time, you have learned how to use our formula for arithmetic sequence to solve such type of problems. Now it's time for you to practice what you've learned today. Try to answer the following problems. On a sheet of paper, please solve the following problems. Show your complete solution. You may also pause our video for you to have enough time to work on these problems. Now let's go back to the problem a while ago. So the answer a while ago is 12,000 pesos, but we use the listing method, or we list down all the numbers until we come up to the 20th year. Now I'm challenging you to use our formula in solving this problem. Pause our video for you to have enough time to work on this problem. Does your solution looks like this? If yes, that means you have learned our first topic, which is solving problems involving arithmetic sequence. So again, I'm Sir Ron Alfiuson, mathematics teacher of Calaba National High School, saying thank you and God bless. Thank you for watching.